If a patient's test result is positive, what is the probability that they actually have the disease? That is not sensitivity, it is the positive predictive value. And if the test is negative, what is the probability that the patient genuinely does not have the disease? That is the negative predictive value. In this video, I will explain both measures using a 2x2 table, show you how prevalence affects them, and work through an MRCPsych style calculation. Hello everyone, welcome to Crack Your MRCPsych. In the previous statistics video, we discussed sensitivity and specificity. Sensitivity and specificity start with the person's true disease status. Predictive values work in the opposite direction. They start with the test result and tell us how much we can trust that result. And this distinction is the key to answering most of the examination questions. Let's begin with a 2x2 table. So across the top of our table, we have disease present, disease absent. Disease present and disease absent. And down the side we have test positive, test negative. So that gives us 4 groups: true positive, false negatives, false positives, and true negatives. A true positive, now what is true positive? True positive is someone who has the disease, that is the disease is present, and the test is also positive for them. A false negative means someone who has the disease but tests negative. False positive means someone who does not have the disease but tests positive. And true negative means someone who does not have the disease and also tested negative. Now, positive predictive value equals true positives divided by true positives plus false positives. Positive predictive value, in fact, asks the question that among all the people who tested positive, how many genuinely have the disease? So, in this case, the denominator will contain true positives plus false positives. That means everyone who has got a positive test result will be included in the denominator. Now, for example, imagine that 100 people test positive. Of these, 80 genuinely have the disease, while 20 do not. So, the positive predictive value is 80, that is, who have the disease, they are the true positives, divided by the true positives, that is 80, plus 20 who are false positives. So, that is 80 divided by 100, and that gives 80%. Therefore, when this test produces a positive result, there is an 80% probability that the person genuinely has the disease. Now, let's see what is negative predictive value. Negative predictive value asks, among all the people who tested negative, how many genuinely do not have the disease? The formula is negative predictive value equals true negatives divided by true negatives plus false negatives. So that means the denominator contains all those people who are tested negative. For example, imagine that 200 people tested negative. Of these, 190 do not have the disease while 10 actually have it. So the negative predictive value will be the true negatives, that is 190, divided by the total negatives, that is 190 plus 10, that is 200. So 190 divided by 200, which gives us 95%. So what is the inference? When the test is negative, there is 95% probability that the person genuinely does not have the disease. Now, how to remember the difference? The easiest method is to begin with the test result. For positive predictive value, look at everyone who tested positive. For negative predictive value, look at everyone who tested negative and then ask how many results are correct. So, positive predictive value means, can I trust a positive result? Negative predictive value means, can I trust a negative result? Do not begin with whether the person has the disease. That approach is actually used for sensitivity and specificity, not for positive and negative predictive values. So here we need to start from the test result and look at to what extent we can trust that result. Now let's work through a complete example. A diagnostic test is given to 1,000 people. The results are 180 true positives, 20 false negatives, 80 false positives, 720 true negatives. So let's first see what is the positive predictive value. So positive predictive value, the numerator is the number of true positives. So look at the true positives, that is 180, and the denominator would be all positives. So true positives and false positives. So 180 plus 80, that gives us 260. So it will be 180 divided by 260. Okay, now let's see how we can calculate the negative predictive value. So for negative predictive value, the numerator will be true negatives and the denominator will be all negatives. So true negatives in this case is 720, and for all negatives we need to add 720 and 20, so 740. So 720 divided by 740, that will be the negative predictive value. Now, it is important that we understand the effect of prevalence on positive predictive value and negative predictive value. This is one of the most important examination points. Positive and negative predictive values are affected by the disease prevalence. So when prevalence increases, positive predictive value increases as well. And this happens because in a population where the condition is common, the positive result is more likely to be truly positive. And when prevalence decreases, the opposite happens. So positive predictive value decreases while negative predictive value increases when the prevalence decreases. A simple way to remember this is more disease. That means an increased prevalence means positive results become more believable. So the positive predictive value increases with more disease or more prevalence. Less disease means the negative results become more believable. So when the prevalence decreases, the negative predictive value becomes more believable or negative predictive value increases. Now imagine screening for a rare disorder in the general population. Even if the test is reasonably accurate, many positive results may be false positives because very few people in that population actually have the disorder because it is a rare condition. So in that case, the positive predictive value may therefore be relatively low. If the same test is used in a specialist clinic where the disorder is much more common, a positive result is more likely to represent a genuine disease. The positive predictive value will therefore be higher in such a specialist environment or a specialist clinic compared to a general population where the disease is comparatively rare. And this is why predictive values from one clinical population cannot automatically be applied to a population with a different prevalence because the disease prevalence affects the predictive values. Now, let's compare it with sensitivity and specificity. Sensitivity asks, among people who have the disease, how many test positive? So it starts with the disease status. Specificity asks, among people without the disease, how many test negative? So sensitivity and specificity, they start with the disease status, whether the person has the disease or does not have the disease. Now, positive predictive value and negative predictive value starts from the opposite direction. Positive predictive value asks, among people who tested positive, how many have the disease? Negative predictive value asks, among people who test negative, how many do not have the disease? The words may look similar, but the starting point changes. Sensitivity and specificity, they start with the disease status. Predictive values start with the test result. Now, let's quickly revise through some of the exam questions here. Which measure answers, if the test is positive, what is the probability that the person has the disease? So it has started from the test result. So it is one of the predictive values and it is talking about positives. So the answer is positive predictive value. What happens to positive predictive value when prevalence increases? So when there is more disease, we can believe the positive test more. So the positive predictive value will increase. What happens to negative predictive value when the prevalence increases? It generally decreases. Which formula uses true negatives divided by true negatives plus false negatives? So everything is about negatives. So it is negative predictive value. A condition is extremely rare. Would you generally expect the test positive predictive value to be higher or lower? So the disease is less, so positive predictive value should be lower. Now let's quickly revise. Positive predictive value tells us how much we can trust a positive result. And its formula is positive predictive value is equal to true positives divided by total positives. Negative predictive value tells us how much we can trust a negative result. And the formula is true negatives divided by total negatives. As prevalence increases, negative predictive value decreases and positive predictive value increases. As prevalence falls, positive predictive value falls and negative predictive value rises. If you found this helpful, subscribe to Crack Your MRC Psych for Paper A, Paper B and CASC revision videos. In the next Paper B video, we can build on this by exploring the relative risk and odds ratio. So see you in the next video.